Hello everyone, I'm Seok Jang from Anyang University, Korea. Today my talk will be about an image similarity estimation approach based on weighted features. In this presentation, I'll first provide a brief introduction to image similarity estimation. Then color difference extraction will be discussed. In this paper, the color difference feature between the reference image and the input image is first extracted. After that, I'll talk about Gaussian mixture model. In this paper, it is judged that the two images are similar if the weighted similarity between the difference operation and the Gaussian mixture model. After that, some of the experimental results will be presented to evaluate the performance of the suggested algorithm. Finally, I'll conclude my talk. With the rapid development of high-speed wireless network functions and smart devices that provide excellent image quality, various types of applications that can be executed on these devices are spreading. As the number of applications developed for mobile devices explodes, the demand to inspect screens executed in the developed programs is also increasing exponentially. In other words, the tester checks whether each screen of the developed program is displayed correctly. Then, if screens with errors appear during the testing process, there is an excessive amount of work for the tester to request for correction. Therefore, research is needed to intelligently determine whether an input image is a normal or error image through content analysis from various input images. Existing studies for detecting similar images from different types of images received can be found in the related literature. However, the existing methods mentioned above are still relatively low in their degree of completion, and there are disadvantages in that there are many constraints depending on the surrounding environment in which the image is captured. Moreover, the research methods of detecting error images in connection with automated quality check of application program interface are relatively few compared to other existing research fields. Therefore, this study proposes a new method to effectively detect regions different from the reference image by combining and using the difference calculation and the Gaussian mixture model from the input color image. This figure represents the overall flowchart of a weighted feature-based error pixel extraction approach proposed in this paper. As shown in this figure, the algorithm proposed in this paper first detects color errors between the reference image and the input image using a difference operation. A Gaussian mixture model is then used to detect an object expression error between the reference image and the input image. Finally, it is possible to determine the final error of the input image by effectively combining the detected color error and the object expression error. In the following, I'll present the problem of extracting color difference. This slide describes how to acquire the main characteristics that represent the input image. To this end, the image of three channels composed of RGB color space is first separated into each of R, G, and B channels, and then the difference feature for each color channel between the target image and the input test image is extracted as shown in this figure. In this equation, R sub REF of x and y, G sub REF of x and y, and B sub REF of x and y represent R, G, B, and B color values at x and y in the target image respectively, and R sub imp of x and y, R sub INP of x and y, and P sub INP of x and y represent R, G, and B color values at x and y in the input test image respectively. The difference calculation result of each color channel has a value between 0 and 255. If the result value of the difference operation is 0, it means that the pixel value of the target image and the corresponding pixel of the test image match. If the result value of the difference operation is 255, it means that the corresponding pixels do not completely match. This equation calculates the number of pixels whose color values are not similar for each channel by applying the difference calculation result value to all pixels of the input image. In this equation, E sub R, E sub G, and E sub B represent the number of pixels whose R, G, and B color values are not similar to each other in the target image and the input image. TH sub R, TH sub G, and TH sub B have a value between 0 and 255 and indicate thresholds of R, G, and B color values, which are the criteria for determining that two pixel values are not similar in the difference image. In general, in the image processing field, the threshold value may be artificially set to an optimal value for a corresponding domain through repeated experiments. This equation represents the similarity measure for the color difference feature between two images. This measure will be integrated to the Gaussian mixture model feature in the next section. In the following, I'll present the problem of extracting Gaussian mixture model feature. The Gaussian mixture model-based method for detecting an error region from an input image is composed of three steps. In the first step, the initial parameters are set, and then a Gaussian mixture model for the reference image is generated. In general, the Gaussian mixture model can be expressed as in this equation. In this equation, x sub t is the value of the input pixel, and w sub I and t is the weight of the i's Gaussian distribution. Mu sub I and t and summation I and t represent the mean and covariance matrix of the distribution. In the second step, the Gaussian mixture model of the input image is generated, and it is matched with the Gaussian mixture model of the reference image to detect an error region. In the third step, the parameters of the Gaussian mixture model are updated according to whether the input images match. In other words, if a match is made, the weight of the corresponding distribution is increased. Conversely, if no match is made, the corresponding weight is reduced. Through this process, the similarity between the reference image and the input image can be measured as shown in this equation. In this equation, piece of error is the number of pixels where an error occurred, and W and H are the width and height of the image. In this paper, it is judged that the two images are similar if the weighted similarity between the difference operation and the Gaussian mixture matter, as shown in this equation, is greater than or equal to the threshold. Otherwise, they are not. In this equation, alpha and beta are the weighting factors that control the importance of Gaussian mixture matter feature values and difference feature values. From now on, I'll present some of the experimental results. The image similarity estimation algorithm was implemented by using Visual C++ and was applied to various types of mobile application images. To construct test image database, various mobile application execution images were used, which were captured in natural environments where specific constraints are not imposed on. To evaluate the performance of the suggested algorithm, the two methods are compared, that is, color-based method and suggested method. This slide shows some results of the extracting error images with the suggested algorithm. Figure A shows an example of an input color image that normally it shows the execution result screen of the application program used in this paper. Figure B is a test image capturing an execution screen of an application program and shows a test image in which an error that is not normally executed occurred. Figure C illustrates an example of the color characteristics of the R channel extracted from the input image. Figure D shows the dissimilar regions detected from the target image and the test image by analyzing the color and texture features. In this paper, the performance of the proposed error image detection algorithm is quantitatively evaluated. In this paper, a measure like this equation is used, which expresses the ratio of the error images of the program extracted correctly from the input test image to the total number of error images in the test image data. In this equation, IMG sub error represents the number of error images extracted accurately using the proposed algorithm. In addition, IMG sub all indicates the total number of error images present in the input test image. This figure is a graph showing the results of measuring the accuracy performance of the proposed error image extraction algorithm. As can be seen from this figure, the algorithm based on the difference operation and the Gaussian mixture model proposed in this paper accurately detects an error-prone screen in an application program. Now I'll conclude my talk. In this study, I proposed the weighted feature-based content analysis method to robustly detect an error image that is not similar to a reference image from an input test image. In the proposed method, the color error value and the object expression error value are respectively extracted from the input color image using a difference operation and a Gaussian mixture model. Subsequently, the proposed algorithm integrated the extracted feature values using weighting factors. and then calculated a similar measure for error pixel detection. Finally, it was determined whether the input image is an error image or a normal image using the calculated measure. The experimental results showed that the proposed method robustly extracts an error image that is not similar to the reference image by using the weighted feature based on the difference image and the Gaussian mixture model from the input image. In the future, we plan to further improve the performance of the proposed system in terms of accuracy by applying the error image detection algorithm proposed in this study to more various types of color test images. That's all. Thank you for your attention. Thank you.